Oh boy, my chartered accountant is completely stressing me out because the taxes are due tomorrow and he hasn't finished them yet. Still asking for documents. That's very, very stressful. There is enough time according to him, but I want this done a month ago. Anyway, I don't know why people get stressed out about taxes, but I'm one of them. Okay, continuing with smart electrification for end-use sectors, we are looking here at power to heat and cool. Again, we'll look at technology and infrastructure, market design and regulation, system planning and operation, and business models. Starting off from the top, low temperature heat pumps. So if you want heat pump to understand them, I have podcasts on them. Basically, this is very different than air conditioning, where you are using outside air to heat and cool. So it's very energy efficient compared to air conditioner or having heating unit and air conditioning unit, but combining them. Obviously, this works best when you have to do heating. In a place like India, if you don't need any heating, then it's not very useful. So heat pumps have to work at low temperatures so that you can still take outside air and provide heating or cooling. Cooling is okay when you have low temperature, but heating, what do you do? So you have to understand the technicalities of that. Hybrid heat pumps, high temperature heat pumps, waste heat to power technologies, so that every time you are producing energy or using it somewhere, there is always waste heat that can be trapped and used for power. High temperature electricity based applications for industry. You can follow up on what hybrid heat pump means, or high temperature versus low temperature heat pumps. What are the challenges? Obviously, heating and cooling are challenge at one end or the other, low temperature or high temperature, because you want to use the same thing for heating and cooling, obviously, right? So high temperature electricity based applications for industry, low temperature thermal energy storage, right? Very easy to take things. Let's say you have very high temperatures. Can you use it to heat something like a refrigerant or a sand or bricks or whatever and store thermal energy? But what do you do at low temperatures? You have to also reduce the loss of heat when you have low temperatures. If you stored heat, it can get lost to the ambient, right? So I'm being very kind of minimal here, but you have to follow up on the details if you are interested. Medium and high temperature thermal energy storage, so all ranges here. Fourth generation district heating and cooling. So these are units where you are kind of doing things at a large scale, and you're let me make sure that I didn't say anything wrong. So district heating and cooling, is that what I said? Yes, it should be. So these are ways in which you can minimize energy use by providing all, let's say, commercial buildings or malls and other office, whoever, some centralized heating and cooling, so that each one is not running their own unit. Fifth generation DHC, so sorry, fourth generation and fifth generation DHCs, depends on where the technology is and where you want to go in terms of efficiency, energy use, and being able to run on renewables and so on. IoT for smart electrification, Internet of Things. Obviously everything is connected, so you can monitor, and there are concerns that they can be hacked and so on and so forth. AI for forecasting heating and cooling demand. This is something I know because we do this. You take weather forecasts and then use data, let's say from energy suppliers or purchasers and users, and you do AI forecasting at individual household level or some grid level and so on, to say what is coming next. You want to do this by hour, by the day, so you know when the peak demand is coming, be ready for it, and so on and so forth. Also to manage intermittency of the renewable energy and so on. Blockchain enabled transactions, so that the efficiency of tracking many users is there in the system, as well as it is itself running automatically or autonomously. Digitalization as a flexibility enabler, and in market design and regulation you have dynamic tariffs, thermal load flexibility, flexible power purchase agreement, standards and certifications for improved predictability of heat pump operation. Everything sounds intuitive, so I'm running through them. You can follow up on the document. As I said, it's 200-page long. Energy efficiency programs for buildings and industries. You want to incentivize commercial operations and industries to be energy efficient. So there are of course regulation and enforcement, but incentivizing with programs always works better. Building codes for power to heat solutions, so that you're generating power but also providing heat to the buildings. And building energy requirements are going to be one of the biggest by 2050 according to all projections. Streamline permitting procedures and regulations for thermal infrastructure. So that's going to be new in terms of electricity transmission versus thermal infrastructure. In system planning and operation, you have holistic planning for cities, heat and cold mapping, coupling. So you have properly planned operations with all these lookup tables, for example, coupling cooling loads with solar generation. Smart operation of thermal inertia, smart operation with thermal inertia, smart operation with seasonal thermal storage. So you use natural variability to benefit in terms of thermal storage. That's why we talked about low temperature and high temperature operations here. Smart operations of industrial heating efficiencies and smart operations, so you are not leaking. Combining heating and cooling demands in district systems, that's what DHC is all about, but you need to think of it in terms of systems planning and operation. And business models, of course, aggregators are needed so that they are aware of, they manage a town, a neighborhood, or bunch of industries, so that they have a good idea of the demand, when it's coming, how it varies, how to buy and sell power, and so on. DERs for heating and cooling. So again, DER is distributed energy resources, so that you have local production. Not everything is not utility scale. You have a local solar grid, wind, maybe hydrogen, and so on and so forth. Heating and cooling as a service, so that people offer you this in some kind of a retail as opposed to aggregators, let's say. Waste heat recovery from data centers, which are coming up over, and everybody wants to save everything, and that cloud storage is going to be growing exponentially and requiring tremendous energy. So big players like Amazon, Microsoft, Google, and Apple keep saying they do all the data centers on renewable energies, because basically they don't want to pay so much for energy. Anyways, eco-industrial parks and waste heat recovery from industrial processes, circular energy flows in cities, booster heat pumps. So you can go and read the details on how those are planned to be designed. Community owned district heating and cooling. This works well in the UK, where towns own the utilities at this scale, so they manage it, and co-ownership, co-production is always the best way to manage commons, and this is common. And in my adaptation sustainability course, I have a nice series of podcasts on sustaining the commons from a book by Andrews and Janssen, which is based on Eleanor Ostrom's work. You remember she won the Nobel Prize and died about 10 years ago, maybe. Community owned power to heat assets. Again, community ownership is always important and amazing. Maybe I should plow through and read some more of the power to hydrogen. Should I? How long am I here? I'm 9 minutes, so maybe I'll leave it and come back and do power to hydrogen separately as an end-use sector. Allows me to be relaxed about recording it and not be rushed that it'll get too long. If the podcast gets more than about 15 minutes, I begin to get nervous, because the attention span is supposed to be somewhere between 7 to 12 minutes. Maybe you have a 1 hour attention span, but most people begin to tune out in long seminars and so on. With that little trivia, let's come back and do power to hydrogen in the next podcast.